Okay. Welcome everybody. My name is Brad Tallis. I've been using Fusion for about 10 years. Uh, Basically, what I'm going to be talking about today is some methodologies with sheet metal, and then ending with sheet metal nesting. So that is part of the manufacturing extension. And so I'll be kind of showing the power and the benefit of that manufacturing extension, especially if you're doing a lot with sheet metal. Like I mentioned, I'm going to show some tips and tricks, especially with I see a lot of questions in regards to certain things. So I'm going to be showing that. If you have any questions as we're going through, please feel free to post them into the chat or the Q&A. I think Chase will be monitoring that, and feel free to interject anytime, Chase, if there's a question that you feel should be brought to the top and mentioned, because usually if there's a question, everybody has the same question kind of a thing. So
Yeah,
please feel free to do that.
we'll
So,
do. We'll do.
okay. So I'm going to start out by, I'm going to go into the sheet metal tab. And the first thing I want to talk about are the sheet metal rules. So right here, sheet metal rules. And I'm going to drag this over here so we can kind of see it in the middle a little bit. And you'll notice that I have quite a few in my list. Your list might look different. And the reason for that is Fusion only comes with a few, about like 6 default rules that you can then edit and change and make your own. So for example, you'll notice steel millimeter, stainless steel millimeter, aluminum millimeter, and then same thing, steel inch, stainless steel inch, aluminum inch. And that's basically the default ones. So if I want to create a new material, so for example, I'm just going to come in here and hover over steel inch. You can see I can say edit rule or new rule. And if I click on that little page icon, that's the new rule. And this allows me to create a new rule, but it's basically using all of the information from that existing rule. So you can see it brought across the thickness, the K factor, some of the settings for the bend conditions and corner conditions. So it's kind of starting from default. So I can give this a name. So I might call this like 12 gauge or something like that. Um, and I'll put in the correct size for that. So that's 0.105. Um, K factor, hopefully you all know what the K factor is, but that's basically a percentage. And if you're looking like at the side profile of a piece of metal, that's where when you're bending the metal, where it doesn't collapse on itself or get squished or get stretched. So think of as you're bending a piece of metal around, and I'll show this in a live example. Some of it's going to get compressed and some of it's going to get stretched. Well, about 44% of the way through the thickness, it's kind of nothing happens. It doesn't get stretched, it doesn't get compressed, and that's what's called the K factor. Now we're going to come back to this miter rip and seam gap. That's kind of the key thing I'm going to show here in just a second. So the first thing here is we took an existing material, we copied it by clicking on the page icon, gave it a name, gave it some thickness, and we're going to come back and change some of the stuff here in a moment. So I'm just kind of doing default for now. And you'll notice it created a new material called steel 12 gauge. Okay. I'm gonna move this out of the way. So now when I come in here and say new component, and all sheet metal has to be components. So I'm gonna say new component, and you can see here that we have two different types. We have standard and we have sheet metal. Now, for whatever reason, in the latest version, it used to show the material down here. I don't know if this is a bug or something that they need to get fixed, but I'm going to click on standard and then click on sheet metal. And now you can see the sheet metal rule. So this is what it should look like. I've reported this to Autodesk, just FYI. So if you don't see the sheet metal rule, just click on the standard and then click on sheet metal. And you should see this sheet metal rule. And I'm going to pick, let me move this out of the way, that 12 gauge steel that I just created. You'll notice I even have like cardboard in here. You can use sheet metal for plastics and cardboard and different materials besides metal. Okay, so I'm specifying sheet metal, the 12 gauge steel. And now I can come in and I'm just going to create just a basic rectangle real quick. And let's just do maybe like a 6x4 in this case. Finish my sketch. And I'm going to create a flange. And when I click on that profile, you'll notice it gives me a particular thickness. And if I were to click on that edge, we can see down here in the lower right corner that the length is that material thickness that we gave it, that 0.105. And if I expand open the sheet metal component, we can see that the rule that it's using is the 12 gauge steel. Okay, now I'm going to go ahead and select these two edges and create a flange. And I'm going to start to drag up. And this is the question I wanted to point out that I see quite often is everybody is like, this is a huge gap right here. And let's say I wanted to weld this edge, these two faces shut. Like maybe this is going to be some kind of like a fuel tank or something like that. And that's a pretty wide gap to try and weld shut. I'm going to go ahead and let's just make that 2 inches tall. And I'm going to come back to that gap here in just a second. I'm going to add two more flanges really quick just to drive home my point here. I selected those top edges and you can see how we're creating a miter. And that's because of this option right here, miter corners is checked. So because I selected those two edges, it's going to automatically miter that corner for us. And again, we can kind of see it's a pretty wide gap. Um, so let's go ahead and just say okay. And let's talk about how do we resolve this? So if I come into the sheet metal rules, you can see in this design is this 12 gauge steel. And I'm going to this time click on the edit icon, the edit rule. And the setting we want to change is this miter, rip, and seam gap. And you can see that it says thickness. Well, it's using a parameter. So it's basically saying whatever thickness is, and you can see it right here, it's 0.105. So this gap right here, so this seam gap, this miter gap, and if we had done a rip, it would be the same width. That is all being 0.105 wide. And you can kind of almost see that it looks like it's about the width of the thickness of our material. So if I wanted to make this a tighter gap, I could come in and I could type in a number. I could say like 0.05 or something like that. Or I could leave this parameter in here and do some equations. So for example, I'm going to say thickness divided by 4. So no matter what the thickness is, it's going to divide it by 4, and that's what the miter, rip, and seam gap is going to be. So watch what happens when I hit OK. Notice how that's much smaller now. The miter and the gap much tighter and closer together. And that's literally all you have to do to change that. I've seen people say, online, we'll just click on this face and drag it to the right and click on this face and drag it to the left, et cetera, et cetera. It's like, no, you don't have to do that. All you have to do is come in here and change this miter, rip, and seam gap. So that's the first tip of the day. In fact, I could even come in here and say divided by 10 and watch what happens when I hit OK. We can see that that even got even closer and we have a really nice tight gap. And this is still a valid model. If I came in here and said unfold and clicked on that and said unfold all bends, sure enough, it unfolds. There's no overlapping geometry or anything like that. Okay, now the second issue is we've got kind of a large hole down here. So let's go ahead and deal with that. So one of the other things that I typically change is in the corner conditions. So this is a 2-bend intersection. I'm going to go ahead and expand that open. And sure enough, you can see that that's like a round relief. Well, I'm going to come in here And you can see there's a bunch of different kinds: square, tear, trim to bend, linear weld, and arc weld. I personally like the arc weld. So I'm going to click on arc weld and say save. And let me zoom up so you can kind of see what that did. So basically it has just a little bit of a flat face, and then you can see an equal gap all the way up. And let me unfold this so you can kind of see what it looks like. But notice how what a nice corner this and miter this edge looks like. So this would be very easy to put a weld bead down all the way along here to seal this thing up. Okay, so let's go ahead and unfold this real quick. And you can kind of see that's what the profile looks like for that arc weld. You can kind of see it. Literally, it's a couple arcs. Now, you could play around with the other types. So I'll show you really quick. I'll come in here, edit. Let's change the corner to bend. So there's arc weld. There's also like linear weld. I'll say okay. And you can see that changes a little bit, looks a little bit different, leaves a little bit more of an open gap there. But you'll notice there's not a flat face right there. So depending on like how you're manufacturing this, you might want to use a particular corner relief. Let me just unfold all bends. So this one you'll notice comes to a sharp point, and it's a straight cut, right? Instead of an arc, a flat face and an arc or whatever. So this would be obviously faster to manufacture, to cut out, but you have a little bit more of an opening right there to fill that in. So again, it's totally up to you on what you want to do there. I'm going to go ahead and set that back to the arc weld. Okay, so that's the first tip I wanted to talk about. The second question I get quite often is creating hems. So I'm going to go ahead and show that really quick. Again, it's kind of a tip. Unfortunately, Fusion doesn't have an automatic hem command right now, so we kind of have to do it manually. So let me go ahead and just do this really quick. I'll go ahead and pick, that 12 gauge steel again. We'll just go ahead and use that. Let's do the rectangle. I'll do the 6x4 again. Okay. And then just create a flange. Okay. Now, if I were to click on this edge and say create flange, and I start to drag, you can see that it's creating a 90-degree bend. And this is what I was talking about earlier, where you can kind of see this area here is going to get compressed, and this outside area here is going to get kind of stretched out as it gets bent. And about 44% of the way up is the K factor, where it doesn't get compressed or stretched. So that's what I was talking about earlier. Okay, so here I have this bend here. I'm going to go ahead and set it to 1, and I basically want to fold this over. So if I start to rotate this over, you're going to see some weird stuff happen. You're going to see my height gets smaller and smaller. And in fact, it kind of disappears. And then it literally just kind of jumps to the other side, and we get some kind of a weird result. So how do I bend this over to create a hem? And there's a couple key things here. The first thing is this height datum, and the second is this bend position. And we basically want both of these to be tangent. So my height datum, I'm going to say tangent to bend. And now watch what happens. When I rotate this, you'll notice that that height doesn't disappear. It's staying 1 inch as I'm rotating this, but this length is changing as I'm rotating. You can kind of see here, and then as I rotate, it's kind of moving over to here, and that's obviously not what we want. So the bend position, I'm also going to say tangent. And now you can see that that little flap is kind of staying put. But the last thing is, and this is the unfortunate part, is if I were to set this to 180, you can see that it errors out. It can't make that bend. So we kind of have to trick it, and we're basically going to type in 179.999. So almost 180 degrees.
Hey Brad,
And so, yeah.
quick question. I apologize to come in a few minutes ago. I had to step aside. But Brian was asking, what's the difference between body and component as it relates to sheet metal?
Oh, yeah, great question. So pretty much everything in Fusion you want to do as components, okay? Um, if you have to assemble parts together, they have to be components. If you're doing sheet metal, they have to be components, drawings, etc. They need to be components. So just get used to always creating everything as components. There is not such a thing as a sheet metal body. It has to be a sheet metal component. Um, so now, with that said, I could import a model and convert it to sheet metal. So you could say that's a body that's being converted to sheet metal. But once again, it's getting converted to a sheet metal component. So yeah, I don't want to go into too much, too deep into the weeds, but just from now on, create everything as components, even if it's not sheet metal. If you're creating flanges or like brackets or whatever, always create everything as a component. It'll make your life so much easier. In fact, we've done webinars on that before, on what the difference between bodies and components are when we talked about the assemblies. We just did a webinar series about that. And we went in depth on why you should create everything as components. So hopefully that answers your question. Um, okay, so now we have this folded over, but there's a huge gap right here. So we've set the tangent, we've set the angle. What we want to do next is do this override rules. And when we click on that, it brings up a bunch of different overrides. And one of them is this bend override. And if we click on that, you can see the bend radius is the thickness of the material, right? 0.105. So I could make this pretty small. So I'm going to say like 0.01, and notice what it does. It makes a really tiny bend radius, and we've now folded this edge over. Okay. Now check this out. I'm going to go ahead and add to my selection list, and let's go ahead and add in that edge there. And now we've just hemmed two of these edges. Okay. Now, once again, you'll notice, because I'm started a different session, it's using the default miter, rip, and seam gap settings. So really quickly, I'll go ahead and modify that. So I'll just come in here and say edit. Let's change the thickness. Let's do the divided by 4 in this case, and hit save, and we'll see that that gets much closer. And then we can even change, it's using a round relief for the corner there. I could come in and let's do the tube bend, and let's just try the arc weld and see what that looks like. And now we can kind of see we get a nice looking corner, and we've hemmed those edges over. Now, obviously, this is a pretty large hem, but I could come in and change the height from 1 to 0.5 or something like that, and everything updates accordingly. So that's another quick tip I wanted to show on creating hems. You guys are getting all the bonus tips here. I'm going to talk about creating lofted flanges next. I'm going to be talking about flat patterns, and then I'll be talking about the nesting extension. So, okay. Moving forward. Yeah, again, thanks for asking that question. If you have any questions, please feel free to throw them into the Q&A. Or the chat, and we'll try and get those answered for you. Another command in sheet metal that not a lot of people know about is the new, I shouldn't say new, it's fairly new, is the lofted flange. And so I'm going to show this command. Let me see, I can see a couple chats coming in real quick. Okay,
All
so
good,
yep,
yeah.
recording. Okay, we're all good. Okay,
Yep.
okay, good. Um, so let's go ahead. I'm in sheet metal. I'm gonna, again, create a new component. Um, I'm just gonna stick with the 12 gauge steel since we're comfortable with that. Actually, you know what? I'm gonna do, well, I'll just leave it the way it is for now. I'm gonna say, okay. And let's start by, actually, you know what? I'm going to open this file here just to kind of save some time. So I'll explain what I did here. I created two sketches, okay? Um, so I have my component. In this case, I'm using the steel inch. And then I created this sketch. Let me go ahead and edit this, where I created an 8x4 rectangle. And then I filleted the edges with a radius of 0.5. Okay. And then I created an offset plane. So that is under construct. I did offset plane. And then you can just click on a plane and then you tell it how far you want that plane to be offset. So I told it to offset, in this case, 6 inches, it looks like. And so it's basically creating a new plane 6 inches up. And then I created a circular sketch on there with a diameter of 3.5. Okay, so that's just kind of how I created those two sketches. If I go into sheet metal, I can come in here and create a flange. And by default, it's set to this edge flange. And that's what we typically think of sheet metal. But you'll notice there's this other command here called lofted flange. And if I select on that, it's asking for the profiles. So I'm just going to click on that profile there. And then I'm going to click on this profile here. And you can see how quickly it created the transition between kind of a rectangular shape to a circular shape. Now there's lots of options in here. I'm going to kind of walk through and kind of show you what they do. Um, so we can see the first one is this orientation, which side. So it's kind of hard to see, but here's the circle. So it's adding the material to the outside. If I were to say side 2, you can see it's adding it to the inside. So you have control over, the overall diameter, for example, or you could say it's, centered through there. Then we have the two different forming types, and this is break form or die form. And what you're seeing on the screen right now is break form, where they're using a break to bend, little creases into the metal to create these bends. If I click on die form, this is kind of like a roller die where they're rolling it or shaping it somehow. And so you don't see those creases. We'll talk about that. We'll come back to that here in a little bit. So I'm going to go back to the break form. And then you have different facet controls. So chord tolerance, facet angle, facet distance, or facet number. So you can kind of see here, we've got the facet control. Um, so we're going to go ahead and change to facet angle. And you can see, for example, I could set it to be like every 15 degrees. It'll do that. If I change this to 10 degrees, you can see now it's going to bend every 10 degrees. I could also do facet distance where I want, each of these bends to be, let's just say every 0.75 or something like that. And so each of these bends are, 3/4 of an inch long. Or I could come in and do facet number. So you can see 5, 4, 3, 2, that kind of a thing, which is what I typically do is the facet number personally. Okay. So that is the flange. Now, if I hit OK, we're gonna run into an issue. If I try and unfold this and I click on a stationary object that says it's not connected to any bends, I can't unfold this. And the reason for that is it's basically solid all the way around. There's no place to unfold it from. So we need to basically create a rip or a tear or something like that. Now, what's cool is Fusion has this under the modify menu has this rip command. And I'm going to move this. You can see it says face, edge, or vertex. So I'm going to go ahead and let's just maybe click on, I'm just going to zoom up and click on this face right here. And you can see that it basically ripped that face away. So I'm going to go ahead and say, okay. And now if I were to say unfold, click on that and unfold all the bends, we now get the flat pattern layout of what that would look like, unfolded flat. So with these, flange um, extrusions, you do have to, or lofted flanges, I should say, you do have to rip a face. Now, let's say I didn't want to rip it right there. I actually want to rip it down the center of this flat face right here. That's where I'm going to weld it together or something like that. Well, if I come in here and say rip, you'll notice I can click on like that point there and that point there, and I get a pretty wide gap like so. Let's make that pretty small. Let's just say like 0.1, 0.01, or let's say 0.05. Let's just do something small like that. And you can see that we just created the gap right through the center there, like so. So you can do faces, vertexes, or edges to rip those. So let's go ahead and try unfolding that. And sure enough, we get the same result where it unfolds flat. Okay. And if I were to come in and edit this, and let's change this to the die form, you'll notice I don't get all of those options for, the number of facets or whatever. It's literally going to try and roll the shape. I'll say, okay. Let's go ahead and edit this feature. Um, so I'm going to click on that point there. Yeah, and so this is the, let me go ahead. I'm going to try and recreate the rip. So let me go ahead and delete this guy and recreate this rip. So I'll say that point there, and you'll notice it doesn't let me select the point up here. So using the rolled form, I can't do that rip like I did before, but I can use some tips and tricks here. So I'm going to jump into the solid, and I'm going to do split face. I'm going to click on this face. What's my splitting tool? I'm going to pick that vertical plane right there. And you can see it's going right through the center there. I'm going to say okay. And you can see I just created an edge on that face. And now I should be able to come in here and say rip. And that's an edge. And so now that I click on that edge, you can see, sure enough, I can rip through there, say okay. And it should let me unfold this like so. So that's another tip. If it doesn't let you pick the vertex for whatever reason, you can use, for example, split body or split face in this case to get the result that you want. Okay. Okay, moving on. Lots of stuff to talk about here. I'm going to open up this part here. Another question I get quite often with sheet metal is what's the difference between unfold and flat pattern? Okay. So in sheet metal, you'll notice unfold, and then we also have create flat pattern. And this is kind of the best example I can show you. And this is kind of a simple example. Imagine this is cardboard. So you'll notice I have this tab and it's coming down through a hole, right? So cardboard boxes, you see this quite often where they'll have, a tab that kind of gets pushed down through this hole and it kind of holds the whole thing together. Well, it, in reality, this hole is going to be smaller than the tab itself. That way it's kind of pressure fit together. and it holds itself together. Well, we can't model that because if this face here, if I were to, bring it out like so, you can see, it's intersecting with the other model. This is no longer a valid model. If I were to try and unfold this, it failed to identify sheet metal faces, make sure it's a valid sheet metal body, blah, blah, blah. It's because it's self-intersecting. It won't let us do that. Okay. Now I just undid it. It's no longer clashing. If I were to say unfold, you can see, sure enough, it unfolds. Okay. So what flat pattern allows you to do is basically modify how the part's going to get manufactured. Okay. So really quickly, I just did unfold. I say unfold all bends. I say, okay, I can do things, but this is the actual 3D model. This is how it's going to look. And if I say refold faces, it's going to go back like so. If I come in here and say create flat pattern, it's asking for a stationary face. I'll click that face. I'll say okay. It kind of looks pretty similar, but you'll notice we're now kind of in this flat pattern mode. You can see we've got these blue tabs across the top, and it's allowing us to do things like we can create extrusions and sketches, and we can make modifications and all this kind of stuff. So check this out. I'm gonna over exaggerate here so you can see the point, but I'm gonna grab both of these faces here and do a press pull. I'm going to drag that to be much smaller. Well, obviously way too small, but I'm kind of making a point here. So I'm going to say, okay, and I'm going to say finish my flat pattern. Notice my 3D model is still correct. Okay. It still has the correct size hole and all that kind of stuff. But when I go to manufacture, this is what's going to get manufactured. So if we were going to laser cut or plasma or whatever, this is the size hole that's going to get cut out. Okay. So it really allows you to make changes to your design for manufacturability that you couldn't do for design, right? And hopefully that makes sense. um, So now, like, for example, if you wanted to round over these edges and all that kind of stuff, you could totally do that in this mode here, right? I could come in, click on this edge, say fillet, round over these edges. That's not going to affect the design in any way, right? Okay. But changing, see how you can see the rounded corners there, but changing stuff like this where they would self-intersect or whatever, you might want to, make different widths or whatever for your offsets or whatever. You could do that in your flat pattern. And again, this is what's going to get used for the drawing, for the manufacturing, like when you go to, the manufacturing tab or workspace. That's what's going to get used. And you can even see right here, for example, I could say export flat pattern as DXF. Okay. In fact, I'm going to do this right now to show you another bonus tip. I'm going to say export flat pattern as DXF. I'm just going to go ahead and say okay. And I'm just going to, let's just put this in my downloads. I'm going to call this, I'll call it export SM or something like that. I'll hit save. And the reason I wanted to show this is you'll notice in the flat pattern, it's showing like the bend line, it's showing the tangency lines, etc. If I were to import this DXF back into Fusion, so I'm going to go ahead and pick this plane. I'll select that DXF file. right from there. Notice this result right here. So sure enough, you can see the smaller rectangle like I told you. But then you also see all of these lines, and I see this question quite often. They're like, hey, whenever I export a DXF, I get all these extra lines that I don't want. So here's a neat trick. You can bring it back into Fusion, and you'll notice it has these DXF layers. So for example, outer profile, I could turn that on or off. Interior profile, so you can see how it's turning that rectangle on or off. Bend, so it's turning on or off the bend lines, or bend extents. So if all I really wanted were just the profiles, I'm just going to turn off these two bend extents, or bend and bend extents, and now I have the outer profile and the interior profile, and that's it. So that's kind of a cool little trick. Um, I can turn those guys off. I now have this, and I could export this as a DXF if I wanted to, or whatever. So you do have the flexibility to turn those on or off. Okay, let's get to the nesting part. So, okay, I'm going to close a bunch of these. So again, we kind of started out with just talking about different sheet metal tips and tricks. Now, let's say you've designed a sheet metal assembly and you want to manufacture that assembly. And I have a design here. I'm just going to bring in this audio rack, for example. Let's go ahead and load this up. So you can kind of see here, it's got a bunch of sheet metal components in here. These panels, some plates that kind of hold the thing together, the upper panel. But then we also have some parts in here that aren't sheet metal, like this handle, the caster wheels, and then all of these little, rivets or studs that are kind of holding everything together. So I've assembled this whole thing and now I want to lay it out. And this is where the nesting really comes into play. And it is part of the manufacturing extension. So you can see right here, the manufacturing extension, very, very powerful. Has a bunch of CNC machining type stuff, which if you're doing a lot of CNC stuff, definitely worth the manufacturing extension. But then you'll notice it says here nesting and fabrication, and then metal-based additive manufacturing also. Okay, so I'm going to just kind of do a high-level overview of what you can do with nesting. So here's my design. The first thing I'm going to do is basically say I want to create a nest. So I'm going to do what's called a nest preparation. So I just click on this nest preparation, and you can kind of see it analyzes my model or my design for me and figures out what makes sense to nest. And you can see that it automatically checked all of these parts, but then it's not going to include the handle, the caster wheels, and those 16 studs because they didn't really analyze as sheet metal components. So I'm going to go ahead and say okay. And then we're going to jump over into our manufacturing workspace. Okay, so the next thing we can do, and I'm just kind of going to walk through this, is specify our sources. And this is almost like a bills of material type display. And you can see that it used the thing that we just did where we said find all the parts that can be nested. It's now grabbing that information and it's finding out there's one lower panel, there's two side panels, there's four plate panels, etc. And if I click on any of these, you can see that it brings up a description and information over on the side. Okay. So for example, I'll click on this plate panel and we have a lot of options. Again, I'm not going to spend too much time on all of this, but we can override the quantity, how many we want to make, the priority, is it going to cut this first before it cuts something else, what's the grain direction, etc. Um, hopefully, let me just check my battery really quick. 29%. Hopefully we make it through the next 20 minutes. um, Okay. Yeah, if I drop off, I apologize if my computer dies. My power supply did not make it with my computer, and so I'm running on battery. So, okay, I'm going to keep going through here. So we basically specify all of the parts that we want. We can override them if we want to. I'm just going to go ahead and say okay in this case. And then we can create a nest study. And this is kind of where all the magic happens. So broken down into multiple tabs, job quantity, we're going to do a single value, and we can see, we're just going to do one quantity of these. I can come over here and once again, I can specify, do I want these parts nested? So you can see 6 shapes are selected and 11 parts are going to be nested because of that bills of material. So there was 2 of some and 4 of some other ones, and etc. And if I hover over these, it kind of gives me a preview of each of those. Then we have some packaging, and this is basically the material that we have in stock. And we're going to come back to this because we're going to talk about packaging here in a little bit. Parameters. We want to basically, in this case, we're going to try and minimize the length. And so we're going to try and cram everything to one side of the sheet. We could also say minimize width, or we could also say minimize length and width. We're just going to start with the length. And then I'm going to turn on this include stock, and you'll see what this does really quick when I say okay. So all I really did is say, take all of these sheet metal parts and lay them out using the material that I specified, which was a particular size material. And you can see we ended up with 2 separate sheets. So, and you can see quantity of 1 and then a quantity of 1 on this other one. So here are all of those parts for making this audio rack. So obviously the larger pieces ended up on one sheet, and unfortunately these pieces here can't fit on this sheet here, so they had to go onto a separate sheet, but it's trying to, minimize the length. So this little blue line here is basically our remnant. So this is our remnant that was left. Okay. Now, let's go ahead and edit this. I'm going to go ahead and edit our nest study, and let's just make a quantity of 4, and let's just see what happens. So instead of making one of these, we're going to calculate to make 4 of them. And you can see how quickly it recalculated that and how it organized these pieces. So it can cut 3 of these guys on one sheet, and then you can see a couple more on the other sheet. I'm just going to kind of keep jumping through here. And you can see like it's trying to make it so there's a very little remnant on each of these sheets, and how it organized all of these and how these are really easy to cut. So extremely powerful tool to create and lay out your sheet metal parts. And what's even more impressive is if I had different thicknesses of sheet metal part, like a 2mm and a 3mm in my design, it'll put all the 2mm parts on a 2mm sheet and a 3mm parts on the 3mm sheet. Okay, so I'm going to do something really quick. I'm going to change my units to inches. And then I'm going to create a new material just to kind of show you some of the options that we have. So I'm going to come in here and go into packaging, and let's go ahead and add a new packaging here. So I'm going to say this guy here is length, let's just say 96 by 48. And let's just say a sheet of that costs $300. So I'm going to go ahead and say okay. And now what I can do is I can create another whole nest study. So I'm going to just do another nest study. We're going to keep everything kind of the same, single value. We're going to do 4 of them. We'll do all these parts. But this time, here's that new packaging that I just created. I'm going to add that up here, and I'm going to make it at the top. And you'll notice it's saying packaging uses methods. So as listed, best mix or best size. So as listed, it's going to use this one first before it goes to this one. And you'll also notice it says inventory is infinite. I could say, hey, I've got 10 sheets of this and 6 sheets of this. So it's going to use all 10 before it goes to this one. Or if I said best size, for example, it'll try and figure out which sizes make the most sense. Now, that might mean you have to pull a small piece and then a large piece and then a small piece or whatever, or best mix uses the most cost efficient mix of packaging sizes. Again, depending on what the cost is. In this case, I'm telling it I want it to use the new sheet that I created, the larger one. So that's what I'm telling it to do. So I'm going to go ahead and say, okay, it's going to calculate that nesting study. Give me a second there. And now we can see we get this result here. So we get 6 panels that fit on this sheet. And I'm just going to kind of jump through here really quick. And then we're left with a remnant like so. Now, what's really cool, one of my favorite things with nesting is I can select both of these nesting studies and compare them. So I just selected both of these and I say compare, and it's telling me this one requires 5 sheets. However, this one only requires 4 sheets, but we can see the total cost for this one using the smaller sheets is $1,000. The total cost for this one, even though it uses less sheets, they're a little bit more expensive. It's going to cost $1,200. And we can see the total nested cost. Now that's for the whole study. I could even come in here and say, let's take a look at the nests. And this is what I think really tells the story. You can see like the actual efficiency. So the smaller sheets, it was able to kind of nest the parts better. It has a higher percentage than it did on these larger sheets. So again, this is helping me decide which materials do I want to use. Maybe I want to change the quantity of how many parts I'm making or something like that to see if I get better results or whatever doing my nest, et cetera, et cetera. But I'm able to actually analyze and look at the results in this nesting result. In fact, you can kind of see here's this large remnant here, and there's hardly any remnant here, and that's why this efficiency was better on this one. Okay, and then lastly, let's go ahead and take a look at one of these. I'll go ahead and do this one. Now I'm ready. Let's just say we're going to use this one here. I'm ready to manufacture it. So I'm going to go ahead and right mouse click, and we have a couple options here. It's kind of neat. So not a lot of people know about this. So it created this nest, and I can come in here and say edit manufacturing model. In fact, let me see if there's a better um
And real quick, Brad,
yes,
um,
yeah, go ahead.
Patrick had sent us a question. He was
Yeah.
asking, he said he knows that this is sheet metal, but does Fusion have the same nesting for sheet goods?
For sheet goods.
Yeah, I'm not sure if that was a typo or not.
Can you maybe have him explain a little bit more?
Yeah, Patrick, if you can send a little bit more context, might be able to help with the question.
Actually, here's a fun tidbit. The US Navy actually uses fusion nesting to lay out how they put their airplanes on the aircraft carriers. They actually have models of their airplanes and the aircraft carrier, and they use nesting, and they say we need X number of these airplanes and X number of those airplanes, and it uses the nesting
Hmm.
analogy or algorithm to lay out the airplanes. It's pretty impressive.
Yeah, nice. And
Okay.
Patrick did clarify. He said like cabinet parts.
Oh, okay. So so yes, you can use this. Yes, so this is for sheet metal goods. Yes, you can use it for plywood, for whatever. You can definitely do that. One thing I didn't talk about today is also with the manufacturing extension, you get this arrange functionality. And a lot of people will use this for some of the woodworking type stuff. It's kind of similar to the nesting. Um, I would say the nesting is probably more for your sheet metal type stuff. And if you're just doing woodworking, you could probably get away with the arrange, but you do need to have the manufacturing extension to get all of the benefits of what you get in the arrange, and it allows you to pretty much do the exact same thing where you can specify what's the size of your material that you want it to lay out on, grain direction, frame width, object spacing, etc. Does it allow partial arranges, and it basically kind of nests those parts together. I would say the nesting extension really is more for like if you're doing different thickness materials like we have in here, um, with different sheets and all that kind of stuff. So yeah, maybe we should do a follow-up webinar on just the arrange, more for like the furniture side of
Mhm.
things. So,
Yeah,
but okay, where was I? Oh yeah, I'm sorry. Let me go back into manufacture. I just wanted to show really quick that once you have this nested or arranged, you can then do stuff with it. So for example, I'm going to say edit manufacturing model, and I'm just going to go ahead and click on this part here. You can see it's the handle cover, and I could come in here and say move. So even though it's nested, I can actually move this to a different location if I wanted to for whatever reason. So the nesting got it close, and then I could tweak it if I wanted to, which is kind of cool. Okay. And then you also have the ability to right click and say create setup from manufacturing model. And what this does is it takes you, it basically creates a setup and allows you to specify, am I cutting this out with a CNC router? Am I cutting it with a plasma? My screen just dimmed. Hopefully my batteries, I don't know if it's sharing that way or not, but so you can see here, we're doing operation type cutting. I can specify my work coordinate system, etc. The stock it's using, the material. I'm going to go ahead and say, okay. And I'm just going to do a cutting profile. What's the tool? In this case, I'm going to say plasma. So let me go ahead and do a plasma and select that guy. Come over to my geometry and I can select my contours like so. I can also have it select similar contours. Let me do that really quick. If I edit this guy, I can say select same plane contours and it'll select all of them. Sorry, all my Zoom stuff's in the way. I'll say okay, and it's going to create the tool paths for me for all of the geometry. So it's going to cut all the way around so you can kind of see how it's doing that and creating my tool paths, and then I can generate my G code and cut these parts out using the plasma, using CNC, using laser or whatever. Okay, so I'm going to stop there. We have 5 minutes left. If there's any questions, now's the time to throw them into the Q&A or the chat.
perfect. We have two that just came in.
Okay.
So I'll start with Andreas said, does the nesting function output a file that can be used on a plasma torch versus having to use a separate nesting software?
So yeah, that's what I just showed.
Okay.
So we just nested these parts, and then I brought that in as that manufacturing model. And by doing that, I was then able to use that layout, and it traced around these shapes with the plasma, with the laser, with I could have told it use my CNC machine with an 1/8" spiral up bit or whatever, to cut around, et cetera, et cetera. So yes, it does it all in Fusion. You don't have to use a separate tool to do this. That's the cool thing. And if we changed something in the 3D model, boom, everything updates. My nests update, my tool paths update, etc. So no, you do not have to use a separate program to do this.
Awesome. And the last question was from John, who has said, what add-on do I need to be able to use wait, sorry. What add-on do I need to be able to use this on a Trump laser?
So, so it's not really an add-on. You want to use the correct post processor. So, for example, now that I've created my profile, I'll go ahead and say post process. And here's where I would select the post for my machine. So you can see, for example, I've got a Haas or Mach 3 or Tormach or whatever. And so if I say choose from library, so you said Trump, I don't know if it's in here or not, but there is, let me scroll down. If it's not in here, there's a web page where you can, yeah, there
There
it
it
is
is.
right
Yeah.
there, Trump laser. So I would select that, select, I'll put that in my local posts. So now I'm telling it to point and use the Trump laser post. And then you can see I have options in here, like allow helical moves, blah, 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 or whatever. And everything's in the way, so I can't see. I'll say post. Let's just see if this works for me. Yeah, so I didn't have it installed on my computer, but if I did, it would allow me to post that out, and then that's what your laser uses to create the to it. That's the G code it uses to run the laser. So I just didn't have it installed local on my machine. So, but that's all you have to do. So
Awesome. I think those were, sorry, I had to step aside to let my dog in. Um, I think those were all the questions unless something else has come in, and it does not look like it. So
okay.
the battery made it. It's a
It did.
testament to the
I
laptop.
mean, I saw the pressure from trying to get everything talked about and
Yeah.
pressure from having my computer not die.
Yeah.
I hope everybody found this beneficial. Again, I kind of aimed this with tips and tricks on some of the sheet metal stuff and then showing the benefits of the manufacturing extension. It really does have a lot of power in it. It's definitely worth it, especially if you're doing some major cam type stuff, but the nesting I use quite a bit um, on some of the furniture design that I do. I use the nesting and the arrange. Um, so yeah, Chase, maybe next webinar we talk about the arrange.
Yeah, yeah,
So
that sounds great.
okay,
But yeah, I just put a link in the chat a couple times. That's the go straight to our contact us page. So if you're looking to get started with any of the extensions with Fusion, or even take advantage of some of our services like the post-processor development that we can also offer, or even edits if needed. That's the best place to get started is to just reach out to us through the forum. That'll go straight to me, so then I'll get it to the hands of the right people as quickly as possible. So that's all for today. We'll have another webinar, same date, or no, not same day, same time, different date, of next week. So I'll have some promotion that'll go out probably early next week. I'm actually out on PTO starting tomorrow, so I'll get the this recording uploaded to YouTube today, and you guys will be able to have access to it from there. So thank you all for joining, and we will see you next time. Thanks, Brad.
thanks everybody. Have a
Yeah,
good rest of your day. See ya.
take care.